Hello. Greetings to everyone. I am Dr. B. Narayanadi, Associate Professor, Department of Mechanical Engineering, Chalwada Ramamma Engineering College, Tirupati. My paper entitled Experimental Investigation of CO2 Laser Beam Welded Joints of AISI 304 and AISI 4130 steel contains here discussing introduction, literature review, objectives, experimental work, uh, results and discussions, conclusions. Coming to introduction, the modern manufacturing industries are concentrated on high productivity and economics, time and quality. So laser beam welding is a fusion joining process that produces a currents of material with the heat obtained from the certain beam of laser. So laser source provides a concerned high density heat source allowing for narrow deep weld bead with high welding speed. So coming to the literature review, so authors are investigated in investigations related to the laser beam welding. So by using 304 with other combinations are investigated. So the influence of process parameter on mechanical properties and bead geometries. So some of them are investigated on only metallurgical aspect and some of them are investigated on mechanical properties, and they suggested that at optimal condition conduct the experiment get as a better quality of weld joint with low cost. And some of them are suggested that when you want to increase the power, so definitely increasing the bead width and penetration depth. You want to increase the speed, so definitely bead width and penetration depths are decreased. So these are the results from the literature from the literature review. The objectives are identified: experimental investigation on the joining of AISI 304 and AISI 4130 steel by LBW using CO2 welding mission, and to study the influence of each process parameter on mechanical properties of the weld joining, to, to find the most influenced process parameter on mechanical properties with bead joint, to study the performance characterization of mechanical properties, to find the optimal combination of process parameters using whale optimization. So input process parameters: laser power, welding speed, beam angle, focal point position, focal length. So weld joint responses are ultimate tensile strength, impact strength, micro hardness, bead width. So investigation materials, compositions and mechanical. So mechanical in the laser welding process, so process parameters are considered, five process parameters with five levels. So according to that design of Taguchi design of experiments, so prepared the experimental combinations. These are experimental combinations. According to the experimental combination, conduct the experiment. Before going for the experimentation, specimen preparation is required. That is preparation prepared by using the wire cut ADM mission. And experiment design, experimental setup mission. Experimental mission is a zoomed view, and it's an experimental setup, and it's in a process. Experimental setup is required to avoid the bending defect. And next one, dissimilar materials. These are the dissimilar material joint, dissimilar welded materials. So we want to observe here in the weld zone, it's an a completely merged. So after welding, so want measure the mechanical properties and weld geometry. So weld geometry, bead width is measured. Tensile test is conducted to measure the ultimate tensile strength. So as per ASTM E8 is considered dimensions, and UTM mission, this is an universal testing mission. So before UTM test specimens, these are the UTM specimens prepared by using EDM, prepared in EDM mission. So after UTS test, the specimens are, these are the specimens below one, and the majority of in the work in the specimens fail at away the weld joint. So impact test is conducted, sharp impact test, and specimen is prepared as per the ASTM E2307. Specimens of impact test and tested impact test. Micro hardness measuring. So these are Vickers hardness measurement, measurement at hardness at cross section of the weld zone. That's why the species are here mounted, hard mounted. Coming to bead width measurement, weld geometry measurement point of view, hot mounted workpieces are used here. So those workpieces are polished and then captured the weld zone and at 20x magnification, and welding expert system software using to measure the specimens. This is it's welding samples and measure the one, and then go for the experimental results. So measured ultimate tensile strength, impact strength, micro hardness, bead width values. So experimental values based on that analysis are conducted here. So ANOVA is conducted for identify the most influential parameter, and performance characteristics are drawn according to the experimental results, and suggested best combination of well joint based on Wales optimization algorithm. Based on the ANOVA analysis of variance is conducted experimental values. So most influential factor is in UTS focal point position, impact strength most influential factor, laser power, micro hardness most influential factor, laser power, beam bead width, laser power most influential factor. So laser power, welding speed, beam angle, focal point position, focal length are significant parameters in UTS, and as well as impact strength. So according to p values are, all the p values are in the tabular, p values are less than 5%, and table values, f table values are also greater than the 6.39. That's why those are significant parameters. So coming to the performance characteristics curves, the performance characteristics curves are drawn according to the experimental results. So when the power is increasing, so mechanical properties are increasing, bead width is also increases. When the speed increases, uh, mechanical properties are increasing, but the bead width is here decreasing. And when beam angle increases up to 91 degrees, mechanical properties bead width are increased. Focal point position when increases, mechanical properties and bead width are increased. Focal in the focal length, when you want to increase the focal length, mechanical properties are here decreased, but the bead width is here increasing. Yeah. Optimization of process parameters. Meta heuristic optimization algorithms are getting increased attention and become more famous in engineering applications due to the facts. So those are easy to understand, can very simple, and can bypass the local optimization. So those algorithms are generally nature inspired meta heuristic algorithms. So coming to bead width measurement, weld geometry measurement point of view, hot mounted workpieces are used here. So those workpieces are polished and then captured the weld zone and at 20x magnification, and welding expert system software using to measure the specimens. This is it's welding samples and measure the one. So experimental values based on that analysis are conducted here. So ANOVA is conducted for identify the most influential parameter and performance. These are the regression equations, second order regression equations, corresponding coefficient values, and multi-objective function is generated in the weighted manner, weighted equation. So these are the individual objective functions. In the weight method, uniformly distribute weight is considered here. So this is a Wales optimization algorithm is run. Before run the program, so require the number of iterations, and lower limit, upper limit, number of variables is required, and with objective functions. So those are the input parameters for the Wales optimization algorithm. So then you want to run the program. So number of times multiple run the program, and so from the multiple responses I'm consider as a 5 readings. These are the 5 readings. The 5 readings I'm conducted the practically again, once again experiment is conducted according to the according to experimental results and optimal results. Conducted the size code test. The size code test value is, tabular value is 9.488, and calculated value is so 8.5589. So it's in a below value compared to the tabular value. That's why it is an a accepted the null hypothesis. So this one is a remaining all those things bead width and micro hardness impact strength are accepted. So coming to the conclusions, so laser power is mostly influenced, and after that focal point is influenced only UTS. Remaining factors are influenced laser power. So performance characteristics on that based on the performance characteristics, laser power, beam angle, focal point position, focal length. So whenever increases, bead width is increasing. So beam angle, welding speed increases, the bead width is decreasing. So optimal combination and model is validated by using psi score. These are the references. Thank you.